Hi everyone, my name is Ali Ben Fatoum and I am an IoT and Smart Cities specialist at Amazon Web Services. I'm going to present you today the Smart Territory Framework Initiative, STF for its acronym. The STF is a set of tools and standardized modules that our partners and customers can assemble together to build and operate sustainable and effective solutions in line with global industry standards and based on the open source offering of the Fiware ecosystem. Before describing the capabilities of the STF, I will first explain why we decided to design and to offer this framework to our partners and customers. At Amazon, we start with customers and we work backwards. We look at their mission and we design solutions that help them solve their problems and achieve their mission. All products, services, and initiatives follow this process. So for the Smart Territory Framework, we first looked at territories' mission and the challenges that prevent them to achieve their mission. Territories have the main mission to deliver a good quality of life for their residents, while facing growing and complex environmental, economic, and social challenges. Data is critical to gain insights that help them optimize their hard and soft infrastructure, but also build and operate efficient and sustainable services. So we designed the Smart Territory Framework to help our customers to tackle the three main challenges that prevent them to collect data and gain the insights they need to provide innovative and efficient services that improve the lives of their residents. One of the main challenges for territories in obtaining data from multiple sources is data silos. Standalone and vertical solutions with a narrow focus create data silos, making it difficult to share the data and collaborate with different departments and with external organizations, but also to extract insights from these different silos. Within a territory, most applications and use cases are interconnected and interdependent. So getting valuable insights implies analyzing data from multiple sources. For example, ignoring the effects on air quality and noise level when measuring the impact of converting a one-way street to a two-way street does not give an exhaustive view. A territory gets smart when it can collect data from multiple and heterogeneous sources and turn data into insights that support informed decisions. But without a clear and holistic strategy with requirements in terms of data models and standards, each of these vertical solutions might have its own data structure, its own security mechanism, its own API, and even its own user interface, making it very complex to gather data produced by these different silos. In addition to these technical challenges, this approach brings business, legal, and operational challenges because procurements, contract managements, and more importantly, data ownership, all these questions have to be considered for each of these different solution providers. Another drawback of relying on standalone and vertical solutions is the lack of economies of scale and mutualization across different solutions using the same technologies and components, like a database, for example. So to summarize this first challenge with an analogy, this approach is like buying a new phone for each new application you need to install. To overcome this challenge, some territories made the choice to rely on a single vendor centralized platform, providing predefined use cases with analytics and visualization capabilities. While having this kind of one-stop shop solution makes it easier in the short term, It limits the capacity for innovation, the flexibility of the platform, and the interoperability with other solution providers. Investing in this kind of single and centralized offering is a one-way door decision. It prevents territories to integrate or replace existing solutions with more effective ones from other vendors. The rapid pace of technological changes makes most of these platforms outdated just a few years or sometimes months after they are deployed. Territories are then captive. They depend on one single vendor, on its pace and cost of innovation, and on the set of solutions and technologies it can provide. Building and leveraging an ecosystem of partners and solution providers, from small and local companies to large and global enterprise, is a key factor in the success of a smart territory strategy. And this implies to interact with an ecosystem of stakeholders and solution providers, to share securely data across different departments and with external organizations. With the STF, we aim to give to territories the freedom to choose the right tools and services they need to improve their platform and add new capabilities and services over time. This brings us to the third important challenge that we tackle with the STF, which is the link between data producers and data consumers. Data producers are all the sensors, applications, solutions that produce data and send it to the platform. On the other side, data consumers are all the tools and capabilities that will consume this data, like mobile applications, dashboards, BI tools, or machine learning models. In most cases, each data producer has its own data format. For example, an air quality sensor will send the data in a format that will be different from an air quality sensor from another manufacturer. When data producers and data consumers are coupled each other, all data consumers will need to be aware of the data format of each data producer to be able to consume the data. Over time, for each new type of sensors, applications, or systems that produce data, all the data consumers consuming this kind of data will need to be updated to integrate this new source. At scale, with hundreds of different data producers, this will lead to thousands of different interfaces to maintain between these data producers and all the data consumers. Modular and built on open standards and data models, the STF enables decoupling data producers and data consumers, making it easier and faster to build a scalable and interoperable platform that breaks down data silos. With the STF, partners and customers can integrate existing solutions and add new capabilities and modules over time to its core. The core of the STF consists of two modules, the STF IoT and the open source Fiware context broker. I will describe these two modules and their capabilities in the following slides. Both modules comply with the NGSI open standard. The NGSI standard, or NGSI LD for its latest version, specifies an information model as well as an API for publishing, querying, and subscribing to data. The NGSI information model is based on entities that are digital representations of real-world objects. They have properties and relationships with other entities. For example, a measurement of air quality would be an entity with its properties like the CO2 level, and would have a relationship with the sensor measuring this value. The sensor would be an entity as well, with its properties like its serial number, and we could relate it to another entity like a floor in a building or a street. The STF leverages the NGSI compliant smart data models, which is a collaborative initiative between the Fiware Foundation and the India Urban Data Exchange, the Open and Agile Smart Cities Network and TM Forum. The Smart Data Models initiative provides multi-sector, standardized, free and open data models compliant with NGSI. There are over 700 data models available in 12 different domains, including smart cities, smart energy, smart water, and smart manufacturing. This initiative provides data models for a wide range of smart city use cases, like smart parking, waste management, air quality, and weather monitoring, but also cross-domain data models like the device data model that is used in the STF IoT module for device management. So using this set of standardized data models, as well as the NGSI API, makes it easy and effective to expand capabilities over time of a platform based on the STF. It gives also access to a global ecosystem of territories and solution providers that are already leveraging these technologies and standards, like the Fiware community. Over 250 territories from more than 30 countries have implemented solutions and platforms based on the open source Fiware Context Broker. It is promoted by industry associations and government bodies like the India Urban Data Exchange, which is an initiative of the government of India, the European Commission via its Connected Europe Facilities program, the Open and Agile Smart Cities Network gathering more than 150 cities worldwide, the GSMA, the industry that represents the interest of mobile operators, as well as the Web of Things and the Digital Twin Consortium. The Fiware community gathers over 500 members worldwide, including global companies like Red Hat, NEC, Orange, Telefonica, and Atos. Since 2020, AWS has been working with the Fiware ecosystem to support customers and partners to operate and build smart platforms and solutions through the STF, bringing multiple benefits, starting with the network effect of using AWS. With an ecosystem of millions of active customers every month and more than 100,000 partners from over 150 countries. So territories can work with global but also local partners to implement and operate their STF solutions. They can leverage the most extensive cloud infrastructure with 84 availability zones within 26 geographic regions around the world. The most comprehensive and broadly adopted cloud platform, offering over 200 fully featured services including compute, storage, analytics, machine learning, and IoT. And this is backed by a deep set of cloud security tools with more than 280 security, compliance, and government services and key features. And all 117 AWS services that store customer data offer the ability to encrypt that data. We designed the Smart Territory framework using open standards and open source because we believe that is good for everyone, and we are committed to bringing to territories the value of open source and the operational excellence of AWS, and to give them the freedom to choose the right tools from any solution provider for each capability or module they add to their platform, including the Fiware Context Broker itself. The Fiware Context Broker is an open source component that enables the connection and integration of different systems, applications, and services within an organization. With the Context Broker, territories can assemble and store information from different systems, eventually belonging to different organizations, instead of having them perform in separate silos. It provides geolocated queries capabilities as well as a subscription mechanism, enabling an independent module like a mobile application to query data filtered by geographical location, but also to be notified with a given frequency or when changes on data take place. For example, you could notify an external system or an application when an air quality measurement is above a specific threshold value. The context broker complies with the NGSI specification and is open source. Territories can choose among the different implementations of the context broker available on GitHub, like NEC Scorpio, Orion, or Stelio, and they can run them using AWS container services like Amazon ECS or Amazon EKS in the cloud. They can also use ECS and EKS Anywhere to run them on-premise. With AWS Fargate, a serverless offering compatible with both Amazon ECS and Amazon EKS, they can deploy their context broker in the cloud without the need to manage infrastructure. And for all customers familiar with OpenShift, they can use ROSA, which stands for Red Hat OpenShift Service on AWS, which is a managed OpenShift in the cloud. Here an example among others on how to leverage serverless services on AWS for automatic scaling, built-in high availability, and a pay-for-use billing model to increase agility and optimize cost. We've worked with NEC Laboratories Europe to provide a scalable and available implementation of the NEC Scorpio broker on AWS, using serverless services like AWS Fargate to easily run and scale the NEC Scorpio broker container, Amazon Aurora Serverless to automatically start up, shut down, and scale capacity up or down for the PostgreSQL database used by the broker, and finally Amazon MSK Serverless to make it easy to run the Apache Kafka used by the broker without having to manage and scale cluster capacity. Still serverless and built around the context broker, the STF IoT module expands its capabilities, enabling territories to ingest IoT data at scale from multiple and heterogeneous sources with advanced device management capabilities, like for example, a registry of all the devices and sensors deployed in the territory, regardless the operating model, the technology, and the connectivity used. The STF IoT module offers digital twin capabilities, enabling territories to store and retrieve in real time the current state of every registered device. It also consists of an IoT data lake built on Amazon S3 that territories can use to store, query, and generate insights about their IoT data, but also to easily visualize them. The STF IoT module is synchronized in real time with the context broker, so any change that occurs in the STF IoT module is replicated in the context broker and stored as well in the STF IoT data lake. These both modules, the STF IoT and the Fiware context broker, forms the core of the STF. And once the STF core is deployed, you have set the foundations for your platform. You can now easily add new modules and capabilities, new data producers and consumers over time. You can also integrate your existing applications and legacy systems. Your data consumers are decoupled from your data producers, so you can build independently each of your data consumers, whether it is a mobile app, a high-level API, or a dashboard, because the information model is standardized and known in advance. And it is the same for the data producers. The only process needed to integrate a new source of data is to transform the source data format into the data model relevant to the use case before sending the data to the STF IoT module. And for any new source of data, you would not need to change your data consumers if they already consume this type of data. It means also that you can build shareable, replicable, and reusable end-to-end solutions based on these modules that you and your customers can easily deploy and update. And we've made it even easier to configure, deploy, and update using AWS CDK. CDK stands for Cloud Development Kit. AWS CDK is an open source software development framework to define your cloud application resources using familiar programming languages like Python, Java, and TypeScript. You can then build, configure, and deploy independently each module of the STF including the context broker and the STF IoT, with ease and in a safe and repeatable manner. You can easily share components, modules, and solutions around your organization, enabling you to rapidly bootstrap new projects with best practices by default. You can deploy as well end-to-end solutions in multiple environments, whether for testing, for productions, or also share these solutions freely with the community. Finally, you can start building your smart solutions leveraging the no-cost open source catalog of modules and samples of solutions that we offer on GitHub. A great example is the city of Drancy in the suburb of Paris in France. After they built their own private LoRaWAN network using AWS IoT Core for LoRaWAN, they deployed the STF Core and built two solutions that they are going to share now with other territories. The first one is a smart parking solution. They deployed LoRaWAN parking lot sensors to monitor parking space availability, especially for parking spots for people with reduced mobility. They can provide to their residents information about the availability, but also ensure that these public resources are used properly. The second one, using the same LoRaWAN network, enables them to monitor the air quality and the temperature in all the schools in Drancy. So they can ensure a healthy learning environment for kids while improving the efficiency of their buildings by, for example, being notified when temperature drops below a certain threshold and check if a window has not been left opened. Another example that illustrates the ease of use and the pace of innovation that enables the STF is the city of Heidelberg. Within a week, the city of Heidelberg deployed the STF, integrated an existing system monitoring the road traffic, and built a dashboard to visualize the data and extract insights. They are now able to easily link the road traffic with the air quality and understand how these two interact. Finally, the example of Serfim demonstrates how a partner can leverage the STF to build its own smart territory offering. Serfim uses the STF as the core component of their platform and are able to offer a wide range of use cases. They build their modules once and they can reuse them. They can also respond to customer needs very quickly. A great example of this is the solution they provided to the region of the French Alps to secure hiking paths by geolocating sheepdog to prevent attacks on hikers. Well, it's demo time. I will show you in this demo how you can quickly deploy the foundation of your platform and start ingesting and visualizing data. So I start with the STF Core stack, which is available on GitHub. You can scan the QR code you see on the screen to get the link. Once downloaded, I first install the libraries with the command npm install. Then I bootstrap the CDK environment for my AWS account. And finally, I deploy the stack. This stack will deploy on my AWS account the two modules that form the core of the STF, which are the STF IoT module and the Fiware context broker. I use in this stack the NEC Scorpio broker. After exactly 28 minutes, the core of my platform is ready and I can get all the information needed to operate and connect my solutions using the STF. I can get from the outputs of the stack the public API endpoint of the context broker, the STF IoT device API endpoint that we will use to provision our devices in the STF IoT registry, and the ARN, which stands for Amazon Resource Name, of the queue endpoint of the STF IoT module. This one will be used to connect my data producers. Let's create our first device in the STF IoT registry. So after setting the API key in the header, I create a device using the STF IoT device API. The payload complies with the NGSILG information model and use the smart data models device. My first device is a LoRaWAN Bosch parking lot sensor, and if I check in the IoT Core registry, I can see my new device created with the NGSILD entity describing my device stored in its name device shadow STF-device. I can check that this entity has been replicated in the context broker by calling the context broker API. Because NGSILD is based on JSON-LD, if you don't provide the context in the request, you get the expanded version of the entity. So I add in the header the context used, which is the Smart Data Models context, and request again the entity. Now I get the entity in its compacted form. You can get more information on this in the GitHub repo of the STF Core stack. I'm ready to connect my first data producer. This data producer ingests data from the LoRaWAN Bosch parking lot sensors using AWS IoT Core for LoRaWAN. The same way, with only 3 lines of command, I deploy the stack. The stack deploys the resources needed to ingest data from the Bosch parking lot sensors using AWS IoT Core for LoRaWAN, including the LoRaWAN destination that describes the AWS IoT rule that routes the messages to the Lambda function that processes the data, the AWS IoT rule that routes the messages to the Lambda function, and finally the Lambda function that decodes and transforms the payload using the NGSILD Smart Data Model parking spot before publishing it into the STF IoT queue. Once the stack is deployed, I can onboard my devices in AWS IoT Core for LoRaWAN using the LoRaWAN destination created. And that's it. I start now receiving data from my sensor, and if I check the list of shadows, I can see a new shadow STF-parking spot storing the data received from my sensor. I check the value, the parking spot seems to be available. Again, I can check that the data is also stored in the context broker. That gives you an example of how you create and connect a data producer. You can do the same for data consumers, and I give you here some examples of data consumers. One that consumes data from the IoT data lake using Amazon QuickSight. A second one getting the data also from the IoT data lake using Grafana. And the last one that consumes real-time data directly from the shadow of the devices. Now, let's look at how you can notify independent systems or applications using the subscription mechanism of the context broker. I will use an air quality sensor to demonstrate that part. So let's create first this device in the STF IoT registry. The STF IoT device API enables you to organize your devices in groups. In that case, I want my new sensor to be in the group air quality. I can check that the device is registered and that it belongs to the group air quality. Now I will create an independent system to receive the notifications from the context broker when data meet the condition that I'm going to set next in the subscription. I will keep it simple. I just need a Lambda function that will log the data received. The Lambda will be triggered by an API endpoint that I will provide when creating the subscription in the context broker. So after creating the Lambda function, I create the API using API gateway. I link my API with my Lambda function, and I can now create my first subscription. I want to be notified when any air quality data received has a level of nitrogen dioxide, which is NO2, above 120. And I only want to receive the NO2 value. I simulate some data from my sensor. The first value of NO2 received is 69. So my system should not receive any notification. I can check that in the logs of my Lambda function. All good, nothing received. The second one received is 125, which is above 120. So now I should receive a notification from the context broker. I can check the logs again, and indeed, I have received the notification with the data requested. If you want to receive all the data, you just need to create a subscription without the watched attributes property. So if I try again with a third value of 130, this time I receive the entity with all its properties. That's it for this demo. To dive deeper on these different steps, you can check out the link of the STF Core Stack on GitHub. So to summarize, you can leverage the Smart Territory framework to build effective, scalable, and interoperable platforms and solutions. Within an hour, you can start innovate, connect your existing application, and focus on the services that improve the life of your residents. That's it for this presentation. Thank you for your attention, and I hope you found it useful and that it will help you build solutions and services that make territories smarter.